Alright guys, this is our water project lecture part 1. This is why you are in an honors class, is because of this honors project that you're doing in this class. You're going to work together and try and help us figure out our water resources here in Phoenix, Arizona. So let me give you some background. Never mind, let me give you the plan. We're going to talk about the hydrologic cycle, where our water comes from, which governmental agencies bring us our water, and how much we overuse our water resources. All right, now the background. Hydrologic cycle. So this is a review, right? But water evaporates off the oceans, condenses into cloud. That's your dew point level. Clouds will rain, and it rains over the surface of the earth, and you'll get surface runoff that can collect into lakes and flow back into the ocean. But you can also get subsurface flow and get absorbed in the ground and actually flow in the subsurface. But generally speaking, we have two types of water sources. You have surface water, which for us we collect in reservoirs, and we have groundwater. Groundwater is nothing but wet dirt. So any place you have dirt, water will seep into the ground and you will get wet dirt. And if you drill a well down to that wet dirt, you can pull the water away from that dirt up to the surface and then utilize it. So we have rivers and lakes that we utilize water on the surface, and then groundwater. For us here in Arizona, well, Phoenix, Arizona specifically, our surface water we get from three major rivers, and you need to know this: the Colorado River, the Verde River, and the Salt River. The highlands for the Colorado River that collects that water are the Utah Highlands, which I've kind of highlighted here in this green, the Rocky Mountains, which are here in this kind of blue to color, and then the Wind River Mountains way up here is also, I should include the Green River that flows into here out of the Wind Rivers. These are your major highlands that collect snow melt that flows into the river. The Mogollon Highlands is the source of water for both the Verde and Salt rivers. So our surface water comes from these three rivers: Colorado River, Verde, and Salt. All right, here's some pretty pictures of the area. Mogollon Rim, pretty rainbow. Rocky Mountains, Rocky Mountain, high. Wind River Mountains, I almost died there. And Boulder Mountain, I spent a lot of time there and drink water that cows had peed in. All great places. All right, the Central Arizona Project is one of the major governmental agencies that brings water to us. And the Central Arizona Project brings Colorado River water to us, specifically through the CAP Canal. This is a big canal, transports water from the Colorado River to Maricopa, Pima, and Pinal counties, basically Phoenix and to some degree Tucson. It gives us 2.8 million acre feet of water, which is our share of the Colorado River. An acre foot equates to about 325,000 gallons. To get that water to us, it requires pumping stations to pump the water 2,900 vertical feet to then flow down to Phoenix. The electricity needed to pump the water that high is the single biggest user of electricity in the state. It's run by a 15-member elected board, and it has a capacity of moving 22,500 gallons of water per second. Boom. This is a huge engineering feat. Here are the water allocations. The upper basin states get 7.5 million acre feet. The lower states get 7.5 million acre feet. California gets a lion's share. Arizona fought tooth and nail to at least get 2.8 million acre feet, which is kind of funny because California has no actual drainage basin of the Colorado River, but they get a ton. And Nevada only got 0.3 because Las Vegas didn't even exist in 1928 when this was made. Nevada's bummed. And Mexico is supposed to get 1.5 million acre feet, but when this was established, this basically you're supposed to have 16.5 million acre feet to give away. Was a wet time period, and so the river can't generate this 1.5 million for Mexico, even though it was established with a treaty. They're not happy about that. Here's what the CAP canal looks like. It's a huge engineering feat. You got siphons, pipelines, tunnels, recharge projects. Super involved. Here's what it looked like to build the thing. Here's what it looks like out in the desert today. And we're running into issues. This is what Lake Mead looks like right now in 2014. It's extremely low. This is the water that gets pumped in the CAP canal. And if this gets too low that it can't actually flow out of the dam, we won't have water out of the CAP, which is currently the biggest source of water for Phoenix. Upstream of Lake Mead is Lake Powell. Lake Powell is doing better than Lake Mead, but is also extremely low. So we are definitely running out of Colorado River water. Here's some more information about the CAP. This is the new Prado Dam that was built for Lake Pleasant. And, oh, sorry, I got a nose itch. They built this dam basically to allow the lake to get bigger, and they pump Colorado River water into this lake, and it acts as kind of a buffer. So they allow the lake to get really high at times when water isn't needed that much downstream, and then get really low when they release a ton of it. All right, then we got the Salt River project, and Salt River project's pretty neat. It utilizes canals that were initially built by the Hohokam people 2,000 years ago. Salt River project has the electricity side, generates electricity. Some of you guys might get an SRP bill. And the other side can deliver over 1 million acre-feet of water a year. SRP was forged by early Phoenicians who they used their homes as collateral to build Roosevelt Dam, that structure right there. And they built the dam to try and prevent a consistent flow of water that didn't generate flooding and didn't go dry in the summertime. Later, there's 3 more dams placed on the Salt 3 on the Verde River. It has a watershed of 13,000 square miles off the Mogollon Rim. And importantly, it also has 250 pumping stations that pump groundwater out of the ground to support this flow of water. In normal years, groundwater contributes to 25%, but in dry years, it's as much as 65%. We've been dry for a while now, so it's definitely more on this higher percentage. As a result, the wells that pump our water, they used to be 500 feet deep, now they're 1,200 feet deep. And if we continue to use more groundwater, that only gets deeper, gets more expensive to pump the water out, and the quality goes down. So we have an annual deficit roughly of 82 billion gallons. Water that's being pumped out of the ground that's not being replaced. It's like a bank account that's running out of money. Oh, and why build dams? We talked about that. Prevents floods and gives you a constant source of water. Here's some cool pictures. This is what Roosevelt Dam looked like. Then it almost actually failed and collapsed. It was a really old dam. You can see it's leaking all over the place. They came in 1993, 1995 maybe, and put concrete on the outside to make it much better, which is good because we want the dam to fail. That's what it looked like to build the thing. That's a rough job right there. Here's Horse Mesa Dam on the Salt River, Bartlett Dam, Verde, and Stewart Mountain Salt River. Here's an example of a well being drilled right here, and among Phoenix, this is actually a well near my house that are kind of dispersed. These 250 wells that pump water out are kind of dispersed throughout the city and supply water to SRP. Okay, so have we talked about? I don't know if you guys. I think we've covered this, but basically, the Basin and Range is because the western portion of the United States got pulled apart like an accordion when we overrode the East Pacific Rise, the spreading center. We basically formed a ton of basins, and then these basins that filled in with sediment then had water pour into that sediment, and now we have a bunch of basins filled with water, underground water. Okay, a bunch of basins of wet dirt and water that we can utilize. And this is great. We pump this water out all the time. We have a ton of water in these basins. But we've been using it so much we're running out. As part of the deal to build the CAP canal, we have the Water Banking Authority. So in the wintertime, we pump water into these basically seeping stations that allow water to seep back into the groundwater. Even so, we overutilize our water 251,000 acre feet. This is how much we overutilize our water of renewable resources, basically our groundwater, by 251,000 acre feet a year. And this is, includes the fact that we get 2.3 million acre feet given to the city annually, 1.4 million from renewable resources. These are our rivers, and 900,000 acre feet from groundwater. Okay, so for the things to know, I want you guys to understand basics of the hydrologic cycle, understand the 2 major watersheds that supply water to Phoenix. These are like the Wind River Mountains, Rocky Mountains, Mogollon Highlands, and Utah Highlands. Groundwater and surface flow from the Colorado, this is supposed to be salt. And Verde Rivers supply water to Phoenix, and the two agencies that supply water to Phoenix, SRP and CAP, or Salt River Project and the Central Arizona Project. All right, guys, the next lecture is going to be about how the assignment's going to work. Thanks, guys. Bye.